Our next speaker this morning is our furthest traveling speaker. He comes all the way from Mexico, Jesus Ramirez Pichardo. Jesus is the head of the Computer Emergency Response Team at the Bank of Mexico. And in addition to many fancy accomplishments, and completing his job, he also teaches IT at several international universities in Mexico and Ecuador. So, Jesus.
Hello, everybody. Good morning. My name is Jesus. I work for Banco de Mexico. Banco de Mexico is the Mexican central bank as Federal Reserve in the U.S. And I work. I'm the head of Computer Security Incident Response Team at Banco de Mexico. I'm here today. Sorry. I'm here today to talk with you about preventive digital forensics. This is a proposal, how to create preventive digital forensics systems to proactively resolve computer security incidents in organizations. Firstly, I'd like to consider the following situation. Imagine that you're driving your car and you have an accident with the other car. Then the police officer comes and says, who's responsible? How do you answer? Typically, of course, everybody says it was the other driver. But do you have evidence to support that point? Is the question. Imagine other situation where you're proactive. You think that it's probable that one day you could to be involved in a car accident. There's a critical risk, a car accident, yes? Then you install a video camera in your car in order to record it all the time. In case of a car accident, of course, you could have evidence before, during, and after the incident. In this history, we can see a service, the car, a critical risk, car accident, and something that I call preventive digital forensics, the video camera, that will record evidence before, during, and after the incident, as we'd say. In a few words, this is my proposal, but in the field of digital forensics. Before to continue, I want to give you some context. What is computer forensics? Basically, computer forensics is the application of some techniques to identify, preserve, analyze, and present data that are valid in a legal proceeding. It's some definition. When we speak of security breach, the computer forensics aims to determine who was the aggressor, where the attack came from, how it was managed to violate the system, and what were his subsequent actions. There are two main goals of computer forensics: to find the attacker and to strengthen the security of systems involved in the incident, applying lessons learned during the investigation, the digital investigation. Then, computer forensics is post-mortem, ergo it is reactive. My new approach, complementary approach to traditional computer forensics, is that we can complement the traditional computer forensics to be prepared to provide digital evidence related to critical incidents most likely to occur. There's a relationship here between incident response and evidence acquisition. This work focus in this point. Basically, incident response is the process of detecting, analyzing incidents, and limiting the incident's effects. When an incident happens, incident handler will take actions in order to return the affected systems to a normal operation as soon as possible. It's comprehensive that, but the actions to solve this incident could modify or destroy the evidence. That's the problem statement. Let me show this diagram. This is an example. Here we are a SQL injection attack, successful. Maybe the network IDS and SIEM generate the security alert to the incident response team and system administrator, but they take a lot of time to review the incident, and they could modify evidence. Then it begins the evidence acquisition process. It doesn't begin in a timely manner in all affected systems. These actions could modify the evidence. If you agree with me in this point, the evidence acquisition should be done simultaneously with incident response. It's the best practice. In all affected systems and networks at the same time in a timely manner without any modification. Then my proposal, as we say, is if it's known which are the critical organizational systems and their information security risk, then configure the systems in such a manner that they facilitate computer forensics. It's a preventive approach, a proactive approach. Again, the example of a SQL injection attack in an organization. Before the incident, we create a preventive digital forensic system, PDFS, that continuously collect evidence remotely, logs, RAM memory, process list, TCP connection, packet captures, Windows registry in Windows servers, for example, and some forensics artifacts. When the incident happens, and after this, we have evidence in the repository, in the preventive digital forensic systems. Then when the incident happens, network IDS and the SIEM could generate the alert, and the incident response team and the system administration could initialize the response, and the computer forensics team could analyze the evidence in the PDFS to support that response. How to create PDFS? Well, I propose a methodology that is based on experimentation, iterations, and learning. Basically, the PDFS there are agents has a repository, remote forensics repository, which preserve and initialize the chain of custody of that evidence. And this methodology could integrate it with other traditional methodologies, best practice. For example, NIST 886 traditional digital forensics has 4-stage collection, examination, analysis, and reporting. The incident response methodology best practice, NIST 861, preparation, detection, and analysis, containment, eradication, and recovery, post-incident activity. And my proposal is here, integrated to these methodologies, best practice, preventive digital forensics. With this stage, analyze, build, and calibrate, we create PDFS that collecting and preserving pre-incident evidence. This is the stage of phases that preventive digital forensics methodology: analyze, building, calibrate, is interactive. Basically, each phase has inputs and outputs. The main inputs are a critical IT service and their critical IT risk. Then the outputs are the PDFS model, in order to build the PDFs, source of pre-incident evidence productions, where can I collect the evidence, and level of granularity of the pre-incident evidence. Maybe, for example, a server could be an evidence, but maybe I don't need all the server, only just the hard disk, for example, or another level of granularity could be just the certain files or logs. The second phase is build, inputs, PDFs, model, source of pre-incident evidence at production that I identified in the previous phase, level of granularity, the pre-incident evidence, and then the output is the preventive digital forensic system. In this point, I build the PDFs. I need to calibrate to adjust the PDFs in order to collect the evidence that I need in base of the analysis, the previous analysis. And with this calibration, this adjust, we have new critical risk detected, new source of pre-incident evidence production, new level of granularity of pre-incident evidence, and training for the IR team and digital forensics team with this knowledge, with this exercise. I put all of this in a case study, together in a case study, in a company that we'll name Company X, that has a critical service for collaboration and file sharing in a FTP server, basically. Here, the senior management will want to know the details if an incident happened with this service in a timely manner and in order to make the right decisions. This is a very basic diagram of the critical IT service. We have a FTP server, the network, and 3 or more FTP terminals. This is the other key input, the critical IT risk. The company has a risk assessment, then the high risk are 3, information leakage, information theft, and intrusion, a security breach. One key activity during the analysis phase is the decomposition. The result of the composition is the levels of granularity that I need with the pre-incident evidence. For example, I can decompose the FTP service and FTP server and FTP terminals. The FTP servers, as we said, has FTP application and the operating system. And the operating system, maybe I could only need the logs, the OS logon logs, for example, and the FTP application, maybe I need just the transaction logs, for example. But maybe I can consider the RAM memory, for example, other forensics artifacts, something like that. Then the key input to analyze phase is the source pre-incident evidence production and their granularity. This table, let me show you, has on the top has the critical IT risk. This one is the source of pre-incident evidence production. As we said, RAM memory of the FTP server, FTP terminal RAM memory, syslog logs of the FTP server, FTP logs, and syslog of the FTP terminals. Then the level of granularity of pre-incident evidence that I need, process list, TCP connection, OS logon events, transactions logs, and so on. Remember the history. The critical IT risk are the car accident, The source of pre-incident evidence is the video camera, and level of granularity is the recordings. This is the other key output of the analyze phase, the PDFS model. As we said, we have agent or agents for each technological component of the service. A remote, maybe one or more remote forensic repository. The agents collect and send evidence to the remote forensic repository, and the remote forensic repository preserve and generate the chain of custody. This evidence, pre-incident evidence, could be logs, RAM memory, process list, TCP connection, packet captures, Windows registry, forensics artifacts. Then this is the build fast. This is the key output, the PDFS. We have the FTP server, and his agent that for example, every hour is collecting and sending pre-incident evidence. We have FTP terminals that every hour is collecting and sending pre-incident evidence to the remote forensics repository. Technically, how can I build PDFS? Depends of the technology that we want to use. For example, open source solutions could be an integration of log management tools, packet capture tools, computer forensics tools, plus software development in-house, for example, in C, C++, Java, Perl, Python, Bash, etc. And commercial solutions like Encase and Xdata, for example. Finally, we have the PDFS, and I need to test it. I need to calibrate, maybe. I propose draw pentest. Pentest is a set of simulated attacks of the real world attacks. In this case, I use pentest in order to calibrate the system. This is an example in this case study. The PDFS is collecting pre-incident evidence constantly. As we say, this evidence is not just logs. It could be RAM memory, for example, or another files, critical files. Then the attacker, maybe with social engineering, the attacker has control over an FTP terminal and execute a tool, for example, wget, in order to do a massive information leakage. Remember that information leakage is a critical IT risk in this exercise, in this case study. For example, with this command, just with this command, we can download a lot of files from the server. Examples in real life, we have both. For example, the Manning case of Snowden case, for example. Okay, in this case study, unfortunately, the attack has been consummated, but in the PDFS, we have some evidence before, during, and after the incident that maybe we can answer the questions to support a solution to the security breach. For example, maybe we can have logs that say me which files are downloaded, where, when, which user, etc. As a conclusion, it's basically, as we've seen today, if it is known which are the critical services in an organization, remember that is the main input in this methodology, and their information security risk, first of all, the critical security risk, then configure the systems in such a manner that they facilitate computer forensics. That is the core of my methodology and the PDFS. And basically, That's all. I have some refs if you need or you want to have more details about this. Thank you for your attention. Thank you for Banco de Mexico for your sponsorship. And I don't know if you have any questions.
I noticed that you don't have network flow in your data collection system.
No. Okay. Thank you.
I have a question. You mentioned at the beginning that one of the goals of digital forensics is the use of results in legal proceedings. Most of us are unaware of the legal effectiveness of prosecuting cybercrime in Mexico. Is there any difference between that in Mexico and the U.S.?
Sorry, I don't hear the first part.
You mentioned earlier that one of the goals of digital forensics is prosecuting cybercrime and using it in legal proceedings.
Okay. Yes.
And so since you're working at the Bank of Mexico, I'm wondering if there are any major differences between the prosecution of cybercrime in Mexico versus how it would work in the U.S.?
I think that this is this slide. This one? About legal proceeding?
Yes.
Yes, yes, maybe. In Mexico, is the authorities begins to implement computer forensics to prosecute some crimes. Yes, there are federal police that have its own cert that do this investigation, these technological investigations, and use computer forensics. And my approach is this is a case study proposal, but I think that it could be implemented in these proceedings. Yes.
Okay. Thank you.
Jesus, just wanted to ask that since you've been at FloCon, if you've considered adding network flow to your data capture repository. Thank you.
Okay. The network flow, we can implement network flow. As we said, he's here. In here a slide, as we said, the PDFs could be an integration of a lot of technologies. Depends on the objective. The objective, for example, if I need to, if we have a lot of transactions, for example, a lot of transactions in the network, maybe a critical tool in the PDFs could be some network flow tool to capture, to do the capture of the flows of the network, but depends of the objectives and the service that I need. For example, in this case, my objective was to protect, to monitor the servers. Then I have evidence of that servers, for example, but if my objective is to monitor the network, protect some network, some critical network, maybe I think that I could integrate that tools, the network flow tools, to this. But my work is focused on the methodology, how can do to building PDFs, but depends of the case. Okay. Thank you very much.